Hi all, can you hear me? So, a quick thing on what we have covered yesterday. For I hope people who have joined with us joined yesterday too. If in case any we got any new participants for the day, then I would like to give a quick overview on what we have covered. We started up with SQL and we understood about RDBMS and we understood about the different RDBMS that are there on the market and what are some of the most predominantly being used RDBMS and the language that we use to communicate with the data inside your RDBMS. And then we saw about MySQL, like how you can have MySQL in your system on your local machine, and then how to start writing queries inside your MySQL. So we have covered up with some basics yesterday on how to create databases, tables, and how to insert values inside it. So I'll take it forward from there for today's session. So again, a quick reminder, please do keep your questions on the chat box. If in case you feel like you need to talk in order to make your question get clarified, please do use the raise hand option. So I will be getting notified on that and I will let you unmute yourself and we can go ahead with the question. Otherwise, you can put it on the chat box. I'll be more than happy to answer it. Fine, so let's begin. So today we'll be starting up with the different operators that we do have in SQL. So now there are three main operators that comes along with your SQL. One is called logical, arithmetic, and comparison. So logical operators are basically some of the keywords which comes under and, or, in, between, not in, and arithmetic comes under plus, minus, division symbol, modulo, and a star. And comparison comes with a less than, greater than, less than or equal to, greater than or equal to, a double equal to, and a not equal to. Now, these are nothing but symbols or operators that helps us to achieve certain operation, right? Could be a simple mathematical arithmetic operation or could be a comparison to compare two values inside an attribute, or it could be a logical operator, which basically means combining multiple conditions or predicates and finding out values that belongs to it. So let me show you how you can achieve all this on your lab. Now, but before that, would like to start with another new point here, which is how to load tables. Now, remember, there is a small difference between inserting values inside table and loading a file into a table. Now, what do we mean by inserting? As you have seen yesterday, when we are inserting values inside the table, we will insert them one by one. Now, in a big data kind of environment or in any other real case scenario, you will not be doing it in that way, like inserting values one by one. Whereas in a training medium, when you're just beginning with your learning, yes, you can use those insert statements. But then once you start working with ideal projects, you will be having a bigger content that needs to be stored inside your table. Now, in that case, inserting will not help. Rather, there is an operation called load that basically helps you to load a bigger data inside my table. So how to do that, I'll show. Please do follow. So on your left hand side under the schema section, go to the schema under which you want to create the table. Right click, click on table data import wizard. Okay, and once you click on it, it will open another window. Here you can use the browse option. Click on this browse and select what is the file that you are looking for in order to load. Okay, now I will be showing you some sample files. Now in this case, let me first load with the very first CSV file called billing. Now click on open and then click on next. Now here, observe, there are two options it will ask. One is use an existing table and another one is create a new table. What's the difference between them? Now, if I want to load this file into a table which has been created before, then you select this option. So the same structure, there is a table which exists before. All I want to do right now is add this new file records also inside that particular table. Then you will use the existing option. What do we mean by create new table is you're going to create a table for the very first time and you want to load the table with this particular file. So then select this option. Now ideally here we are going to use a create new table option because I'm going to create it for the very first time. Now this is your database and this will be the name of your table. Now you can also find another option called drop table if exist. Now this should not be selected by default. Make sure you uncheck it. But what situations, under what circumstances I will basically create it if you want to know. Now whenever we are loading, I want to delete that existing table. Now hope you guys remember the difference between drop and truncate that we have seen yesterday. Right? The main difference between what a drop will do and what a truncate will do. So here I mean like I'm going to drop the table. So the entire records and the structure of the table will be first deleted and a new table will be created for the very first time. Okay. Yes, great. So now again click on next. And when you go to the next stage, you will be notified about the column names. Now, what are all the column names that we do have and what are their corresponding data types? So please observe carefully. In my file, I do have some 6 columns. So all the 6 columns come. Along with that, it understands the data type of them as well. So this is how the table will finally look like. So this is basically like a preview. Now this is how your table will look like once you have completely loaded it. So click on next, click on next, next, finish. Don't make any changes, just you can move ahead and final step, you will simply click on the finish one. Now do a quick refresh. You can find the table being created. Previously it was not there. Now you could find the table gets created. Also, if you want to see, we have seen this yesterday again, the last option, click on that. You will basically get to see all the content inside the table. Okay, hope that's clear. So these are the column names and these are the content inside your table. Now, let's perform our operators, which we have just now seen, because when I want to perform these operation, I need some entries inside my table. And now as you see, I have loaded some records inside my table. So I'm going to perform some arithmetic operators first. So what are the arithmetic? Plus, minus, slash, modulo, and a star. So let's write. Now in my building table, I do have a field, an integer field called building age, right? See on the information section. So what I'm going to do, I'm going to take the building age and I'm going to add 10 along with that. Similarly, I'm going to take the building age and I'm going to subtract it with 10. Building age, multiply. I'm just trying to show you all the operators in one single statement. Okay, that's the reason I'm writing like this. Building age modulo 2. Okay, so basically I'm trying to have all these operators, all these symbols adopted on top of a table. Now if I run it, you can see how the result comes. So these, okay, along with this, I'll take my building age also, so I can see how the values have been changed. Now can you see, please do observe the result. You could find 25 is the actual building age. Along with that, when I 10, it becomes 35. When I subtract 10, it becomes 15. Multiply, it becomes 250. Divide by 10 and accordingly modulo 10. Now, these are the symbols which are meant to do some of the arithmetic operation based on however you apply. Now, instead of having the column name just like this, if you see it, the operation is also coming as a name of a column. Now, that doesn't look so good, right? So if you want to give them a proper name, then you can use a keyword called as. So you can say incremented age. Okay, some name that you feel makes sense for that. Then decremented age. Something like this for all the operation, you can give an alias name. Now see, after I giving the alias name and if I run it, can you observe these two places wherein I have given the alias name? The name of the column got changed. The remaining still exists the same way, like however it was. Okay. Now this is how we can basically use our arithmetic operator. Now you can also use them under the from section. Now in this query, I have did it through my select statement, but if you want to try them in the var class, I showed you about the var class yesterday. So let me show you on the var class also. So I'm going to write this, but under a condition where my building age is greater than 25. Okay. Now what this greater than symbol means? Greater than symbol is one of the comparison operator, right? Because you're comparing two values and finding out which one is greater than or which one is lesser than. Now, when you write this var section, what actually happens is it will first go and take all the records from the table, and in that it will identify what are all the rows which has a building age greater than 25. So for example, in my case, I'll pick this, I'll pick this, right? Within this 20 records that I could observe here. Like the same way, it will take only those records which satisfy this condition, and then it will calculate all this and it will try to display on your output. So let's run it. So select this entire statement, click on run. You could find there were three ages which is greater than 25, which was 26, 7, and 8. And accordingly, their operation happens. So all these symbols that you are using on your select class can also be used on your var class. Okay, now let's do so arithmetic I have showed you completely. Now in the comparison I have showed you greater than. The same way you can change this to greater than equal to, which means it will take all the values from 25 and greater than 25. So now if you have observed, there are three other buildings which comes with value of age 25. So all these values comes, which is greater than equal to. The same way you can do a less than equal to. Less than equal to also you can try, and just a less than also you can try. Okay, so now here it is less than or equal to 25. So if you click on this, you will find all the records it takes falls from 25 and go all the way up to whatever is the minimum value. The minimum value of my age here is 3. Okay, same way I can write a not equal to operator. Not equal to 25 means find out the building age, which could be anything other than 25. So now see, when I run this, I could find all the values other than 25. Can you see 23, 26, and 28? So 25 is basically getting skipped up. So this exclamation symbol and equal to refers to not equal to. Similarly, double equal to you can use, less than equal to, greater than equal to, all other comparison operators we can write. And again, I would like to reiterate the point. These operators can be used on your select section and can also be used on your where class section. Okay. Now coming down to the logical operators. Now what do we mean by the different logical operators? It can be like and, or, in, between, not in. Now let me write some statements for that, and then we can see what does it basically replicate. So I'm reading everything from my building table where my building age is greater than 20 and okay, let me see whether I do have any records for that. Uh, Building age greater than 20, maybe country, let's say whether I have a country which is equal to Finland. So okay, now see, when I run this statement, what is that I'm basically looking for is I want to find out an entry where the country is Finland. Along with that, compulsorily the building age should be greater than 20. Now, if you observe the file, you could find something like, see, with the moment you click on it, it arranges in the ascending. I hope you are able to see that. The moment I click on the building age field, it will toggle to ascending, and then you again click it, it will arrange the values in descending. So now my use case is what? I want everything to be greater than 20 and the country has to be Finland. So now when it comes to greater than 20, ideally it falls in this bracket. So it will compare, is there any country with Finland here? So yes, there is only one country which falls under an age of 26. So that is why when you run this query, we were able to see 26 and Finland. So this is and condition, which means when both the conditions satisfy, then give me the records. Now similarly, you can write an or, means any one of this condition, if it satisfy, you can go ahead and print me the records. See now how it's going to happen. I'm writing either the building age is greater than 20 or my country to be Finland. So if you observe, it will satisfy both. For example, let's say this is not satisfying my first condition, which is greater than 20 because it is less than, but when I come to the corresponding country, it is satisfying this, right? Similarly, I could find multiple other countries, like for example, France. It is not equal to Finland, but then why it is coming? Because it satisfies the condition where the age is greater than 20. Am I clear? Able to get it? Great. So this is how you can write an comparison operator. Now, and or I have showed you, we do have in, between, not in. So let me show that, because in between you will be using them, in, not in also you will be using them a lot. Now let me show you how in can be used. Now suppose my use case is I want the records to fall in from either Brazil or Turkey or Finland. Okay, then any one of these three countries, if I have a record which satisfied, then give me it. So in that situation, I can use an in operator. So to find out records where the country can be any one of this, not specifically to Brazil or not specifically to Turkey, could be any one from these three. Then you can use the in operator. Similarly, you can also write not in operator. Now, what a not in operator will basically do? When you want everything other than these three countries, a negation statement. Then you can use the not in operator. See, now when I run it, just click on this country so that it arranges in alphabetical order, and you could find we don't have any countries which falls under these three. I don't have anything from Brazil. I don't have anything from Turkey. I don't have anything from Finland. Okay, that is your in and not in operator. Similarly, between I'll show. So I'm writing building age between let's say 20 and 30. Okay, which means find out records where the building age falls between this category. So go ahead and see this. I got the starting value is 23 and the ending value is 28, which certainly falls between this range. Okay. So these are the three different operators. You will use them widely in all your SQL statements, and they are very simple and much easy operators to work with. The next comes some of the SQL classes. Now, among these SQL classes, the where class I have showed you yesterday itself, and even now we have seen about our where class. So where is mainly used for applying a predicate or a condition on your statements. Now, similarly, there is something called the like operator. Now, what is this like class or like operator is basically useful for is it basically been used in pattern matching. Now, suppose I'm in need of finding a string which starts with a letter S, or I'm in need of finding a name which starts with a letter S, and after that, there can be a word, and the third letter should always be an A. Now, when you are looking out for some pattern to be found out, then you can use this like operator. Under the like operator, you basically have two symbols to be used. One is called percentage and the another one is underscore. Now, percentage refers to 0 or more characters and underscore refers to 1 character. So suppose now come to the question that we initially asked. I want to find all the names that starts with the letter S. Then you can simply write S percentage, which means the first letter should always be S. And after that, you can have n number of characters inside, 0 or more characters. The same way, I want to find out the name which starts with the letter S and end with the letter A, and in between there has to be only one character. Then you specify an underscore over there. Okay, let me show you that. So I'm going to again take everything from building where country like I want to initially find every country that starts with a letter S, enclose them inside quotes because they are string. Okay. So now I could find Canada and China being only the two countries within my table which starts with the letter C. Now I'm going to change this slightly, wherein I'm going to write C underscore N. In the sense, and after N there can be a percentage, which means the starting letter should be C, the second letter can be anything, third letter has to be N. After that, again, any number of characters can come. So when you click on it, I will only be getting Canada. Now tell me, if I run like this, will I be getting any country? C underscore N. Okay. Because we don't have the Canada will not fall under that, because according to my statement, after N, I mean I don't need any characters, but Canada has some letters after N. So that is why it will not. So your answer is perfectly right. Correct? As you see, I'm not getting anything. So that is the like operator. And the like operators are basically useful in a pattern matching functions. The next is order by class. As you see here on the slide, the next is an order by class. Order by class is mainly useful if you want to see the records in a table arranged in some specific order. For example, see here, order by building age, DESC. I'll come to what is this DESC, but let's first run it. Okay, now when you are seeing the results for this particular query, it is arranging all the building age in the descending fashion. The biggest age comes first and then slowly it gets decreased, which means you are interested in viewing the records inside the table where the age has to come in the descending fashion, decreasing order. Now, when you want to get them in the ascending, just simply remove the word DESC, and when you run it, you will basically able to see. Now you can see there is a change. The records have been changed from the smallest value all the way up to the biggest value. That is your order by class. And you can order by more than one column also. For example, see, I'm writing a building age and I'm writing building ID as well, which means arrange the entire content of your table in the ascending order of your age and building ID. So the very first preference will be given to the age field because age comes first and then the building ID comes next. So see here, whenever there is a duplicate age, which means repetitive value, then it will go to the building ID and arrange them in the ascending fashion. Similarly, see here, 17, 4 and 14. Again, arrange them in the ascending. So based on the order, the preference will be good. So that will be your order by class. Now come to the next one, which is group by class. Now group by is quite important, very useful, and again, one of the very commonly used classes in projects. Now, what do we mean by a group by? See, when I want to perform some aggregate functions, so for this you have to know what do we mean by aggregate functions. Now this is one very, very common term that you use in your RDBMS world. The functions which are helping us to calculate the minimum of a column, the maximum of a column, the average of a column, the sum of a column, and the count of a column are basically referred as aggregate functions. Which means, in our example, we have a field called building age. I just want to find out what is the minimum building age across all the entries inside my building table. Then that means you are trying to use a function called minimum. Similarly, I can calculate the maximum age, average age, the sum of the ages, and the count of every age. Okay, but all these aggregate functions can be calculated within a perfect boundary. For example, I can calculate all these functions, grouping them based on the country. In the sense, when I say I'm going to group them based on the country, and then I'm going to perform an aggregate, which means Let's take the first country, Hong Kong. Now in Hong Kong, imagine there are some 4 buildings, which comes under the age of 2, 10, 5, and 4. Now, when I write group by country and then find the maximum age, then it will go ahead and find, okay, within Hong Kong, I have 10 different entries and the maximum in it is basically 10. Similarly, let's take China. In China, I do have again some 4 entries starting from 4, 3, 5, and 2. Then 5 will be the maximum age within China. So with respect to a particular column, if you want to calculate these aggregate functions, then you can use the group by keyword. Okay, let me show you how you can do. So once you see the answer, the result for it, you will even understand them better. So I'm going to get the minimum building age, something as min age, and max building age. I'm giving it as an alias just so that it will look much neat and readable. That's the simple reason. And similarly, average building age as AVG, which stands for average underscore age, and sum of the building ages. This might not be contextually relatable here, but yes, just to show you that these operations can happen, I'm writing all of them. And I also want to group all of them based on my country. So I want to have my country field also on the select section. From my building, group by country. So what will happen here? Now I'm going to group country wise. So the moment when I run this query, what will happen is internally, it will go ahead and calculate how many. Please understand this. This is quite important. It will calculate how many unique countries are there inside my table. Now, suppose I have some 10 countries, then it will create 10 different buckets. So, for example, India, okay, Finland, Brazil, like this multiple other countries it will create, like how many unique countries you do have, and all the records falling under that particular country will be kept under this bucket. So all India records will be here, all Finland, all Brazil, all Canada will be here. Now on top of this, when I run a minimum, it can easily tell me, okay, within India this is a minimum age or this is a maximum age. Like this it can calculate all your 5 aggregate functions. Let me run this to show you a better view. So if you could see, in country USA, the minimum age of the building is 25. The max is also the same, which means only 25 is the unique age that comes under the country USA. And average, of course, will be the same. The sum is going to be, and the count. Accordingly, for every country, see here, if you observe, none of the countries will be repeating because every country will have only one unique entry over here. Got it? Okay, are we clear? I will show you with one more table also. Let me quickly build another table also. Maybe let's take this one. This will have even much more bigger records. So do a quick refresh and find the table that I have loaded. Click on the third one. So this is the next table that we have loaded, which is called Olympic, which has people participated in Olympic and their age, their country for which they have been participating, and the date, the year, all the details. So now I'm just going to, so you can have the schema running here. So we are going to find out the average medals, average gold medals that has been obtained by every country. So how I can write average of gold, right? And country from Olympic group by country. Correct? When you run this, it will tell you with respect to every country, what is the average number of gold medals. So 1.52, 1.53, like that, we do have records. And if you can observe the countries again, certainly will not be repeated. Okay, are we clear on this group by? Please do put your questions on chat if in case any. Okay. Next comes a key. Okay, I'll cover the having and then I'll come into the limit. Now, having is very similar to your where condition, just with an extra feature wherein having is used, having class is basically used to apply a condition on the aggregated value that you have calculated whenever you call group by. So for example, in this case, I know the average gold medal that has been obtained by every country. So Canada, roughly an average of 1.5 gold medal they have obtained. I mean, if at all you can randomly take across the different sports that they have been participating, randomly the average number of gold medals that they have obtained is 1 to 1.5, right? Now, what I'm going to do is I'm going to find the average gold medal, but the average gold medal I want has to be greater than 2.5. So I'm not taking the countries, or right now I'm not interested in the countries who are having less than an average gold record of 2.5. Okay, so then in that case, it will give you, okay, there is only Finland who is having an highest average of gold records, which is 3, or it is greater than 2.5. Now, maybe if I decrease it slightly to 2, I might be getting, okay, right? So maybe let's say greater than 1. That could help us with little more records. Yes, right? 1 or even 1.5 I take, I will basically be getting a good number of records. So the having condition is basically used when you want to apply a condition on the aggregated value that you have calculated when you use a group by function. So the simple takeaway here is having will come only when you have a group by function on your query. So the calculated value of your group by, which is my average, if I want to perform a constraint on top of that, a predicate on top of that, then use the having clause. Is that clear? And here also you can use the arithmetic operators. Having average of gold is greater than 1.5, and suppose I'm also calculating average of silver medal and you want to apply a condition over there like greater than 1, then here also you can apply. So whatever operators that you have learned previously, you can also combine it over here. That's why I said having is very similar to your where. The only difference is where can be applied on the entire table, wherein having can only be applied on the calculated aggregated value after you apply your group by class. Okay, can I get a notification if things are clear? Please to put an S or a no on. Okay, great. Thanks for that. So now let's move on to our next class, which is limit. Limit is very simple and easy. Now, limit is to limit, as the name says, limit the number of records to view from a table. Now, the moment, okay, let's go into Olympic. Now, when I do an Olympic, I basically have 110 rows. Can you see the total number of rows inside the table is 110. Now, I know it's slightly huge to get view to get just started up with working in tables. So I want to see just a sample in order to understand how the data looks like. Now, in that case, you can write limit 5, which means don't display the entire records. Limit your output to 5, which means just show me only 5 rows from your table. So which means it will display the top 5 records from the table, and that gets displayed on the screen. So that is the use of your limit keyword. You can combine, you can have your limit keyword on all your queries. So that will basically helps us to control the number of records to be displayed. Okay. Now moving on, let's understand what are all the different constraints that we can have on our table. Now, speaking of constraints, what do we mean by that? Now, the simple thing is, see, when I'm building a table, I can say, see, this table should satisfy some condition. For example, let's take, I'm going to build a student-based table. Okay. So for all the students who get enrolled with me for training, I'm going to build a table called student table, wherein every student I will be having a unique number to represent them. Now, the simple constraint that I can ask to be in the table is make sure the registration number for every student is unique, because I can't give the same registration number to two students. Then the point of maintaining the data goes invalid, right? So that can be one constraint that I want to have on my table. Similarly, I'm creating a student name and I want only letters to be there inside my name. So obviously when I create the data type of my name to be varchar, it will only take the letters. Now, I don't want the student name field to be left empty. Now, sometimes when the data entry operator sits and give the value to my table, if in case by mistake they fed the name to be a null, then I should not let my MySQL to accept that record, right? Because it happens to make an error when we are manually feeding the value, but then your system has to control it, but say by saying, no, the student name should have a proper value inside it. Even if I miss it, my system has to tell me that you have missed to enter a value on the name field. So this record will not be taken, right? I can have that as a constraint. Any other constraints you feel that you want to have in a table which contains student based entries inside it? How about the institute name that I can feed inside it, right? I will be having only the default institute name or the university name for all the students, right? Because I'm going to feed the values of students who are studying in that university or in that institute. So I will not be finding, to my surprise, new values inside the university name field. All the values inside the university name has to be same. For example, if ABC is my university name, then all the records should have the university name as ABC only, right? That can be on another constraint. Any other constraint with respect to the course that they have been that they are looking for, or the course that they have enrolled? See, suppose imagine I'm having I'm offering some 4 courses under the institute. Now, when people are manually entering the values, they are giving a field under the course which was not even offered by that institute. Will that be a valid record? Providing a course which was not being offered by the institute. Should I be okay to accept that record? Exactly, I should not, right? So these are some of the constraints, because all these constraints make sense, especially if we start to feed the values manually, or if we start to feed the values from a file which will not be checked for its consistency. Now, in those cases, I can control from my RDBMS side to make sure that I am inserting only valid records inside my table. Records like this with a duplicated student registration number, with an empty student name, with a course name that is not even been offered from the institute, or with a completely different university name. All these are certainly not valid records. Feeding them inside the table will only make things worse, will leads to a lot of inconsistencies and confusions. And for that reason, I have to clearly make sure that I can enforce some constraints when people are interested in loading the records inside my table. Okay, so let's see them one by one. Now let's first go ahead with my very first primary key, which is the most important. Now, what do you mean by a primary key? Let me quickly create a table. So I'm going to write a student. I'm having an ID, which is going to be an int, and I'm going to have the value inside the student ID as a primary key. So explicitly write like primary key. And then something like student name, which can be of a varchar of some 20 entries. Just let's have only 2 values, because my main aim here is to show you the usage of a primary key. Okay. This is how you can call a particular column as a primary key. Now, when I start inserting values inside it, insert into student values, I'm giving some names, right? Now, this is great. This will work. It's a valid entry. Now, how about this? When I try to insert, ideally, it's a duplicate, right? I can't have both Sylvia and Anita to have the same ID. And because ID is being declared as a primary key, can you see the error? Please focus on the error. Duplicate entry 10 for the key primary, right? Which means you have created a field called ID, which is a PK, which is nothing but primary key, and you started giving repeated values inside, duplicate values inside it, which is certainly not a valid scenario. So even if I try to insert the value, my system will not let me insert because the constraint called foreign key is enforced here. Is that clear? Now let me create one more. So now I'm not going to call this as an course underscore ID and the student name, which will be a varchar of 30. Now, after this, I'm going to write a primary key of ID, comma course. Now, what do you think will happen if I write like this? Have a look on it. Any idea what will happen when we do like this? Yeah. So ideally, what is going to happen in this case is it is going to take a combination of my ID and course ID, and that combination has to be unique. For example, if there is a student whose ID is 1 and he has enrolled for a course ID, let's say C01, it is valid. Now, the same way, the student number 1 can enroll for a course, say C02. But can the same student again enroll for the same course? Is this a valid scenario? Is it possible? Will you again enroll for a same course? The same student can again enroll for the same course? Yeah, absolutely not. So he can enroll for some other course, or there can be some other student who can enroll for that same course, but not the same combination I expect. So now when I have a situation wherein a combination should ideally be unique, then you have to write primary key of all those combinations. Now, in short, we can also call this as a composite key because two or three columns basically constitute a single primary key, an unique key. Okay, so a single column can be a primary key, or if you want a combination of multiple columns to be a primary key, then specifically write primary key and within the bracket write what are all the columns that you want to be coming under that column. So let's run this create table command. And now let's try to insert values inside it. Okay, I'm going to have 1 and I'm going to have 1. I called the course ID as an integer, so I'm going by 11 itself. And I have a name. Okay. Have a comma. Now this record, yes, good, it will get inserted, not a problem. Similarly, the same student is getting it's getting enrolled for another course. So still it is valid. And similarly, there is a new student who is getting enrolled for a course, okay, for the 11 course number, which is still valid. But again, the same entry, if I try to insert, can you find the error that it pops? Duplicate entry 111, which means the combo of the PK or a primary key should not be repeated. So it will not let you in. So that is the use of a primary key, which helps us to uniquely identify a record. It can either be a single column or a combination of multiple columns. Okay, so which is our very first constraint. Now let's go to the second one. So we have covered this. Let's go to the check constraint. Check constraint is very simple. When you want a particular column to be holding a range of values or a particular value alone every single time you insert, then you can have the check constraint. For example, I'm taking the same table. Okay, I'm calling this as test one because I'm going to create a new table for this. And here I'm going to write check. The ID has to be greater than 10, which means I'm going to create a new table with ID being an integer column, and the value inside the ID every time the user feeds should always be greater than 10. Now, if at all by any chance, if they have given something less than 10, then that record should not be considered to be inserted. See, I'm running it. Okay, now let's take an insert command here. Let's run it. And now see, I am trying to insert an ID called 1. Will this record be satisfied with respect to this course? It is satisfying the conditions mentioned on this statement? Okay, let's see that. Run it. Okay, very clearly it reports an error saying you are violating the check constraint. The check constraint is quite simple. Insert only ID greater than 10. And now you are inserting something which is 1, which doesn't serve the statement. Now suppose I'm changing it into 11. Now can you see the record is inserted successfully? So like this, you can write a check constraint. Any logic you can write here. You can use all the operators that we have seen before, right? Your arithmetic, your logical, your comparison, any kind of operator that you can use here to check that constraint. So that is a check constraint for us. The next is, let me go to default and then I'll come in the anti-clockwise direction. Okay. Or yeah, let's go in anyways. That's not get much difference. So next is your default constraint. As the name says, when I'm trying to give a default value for a particular column, for a simple example could be a college name or a school name, wherein for all the students, the same college name will only be there. Same student, same school name will only be there because the database is built by that school only. So let's see how you can do. I'm taking the same statement, but I'm going to create a new table. Let me call it as test2 or something. Okay. Now I'm going to have a new column called institute name. Okay, and it is going to be a varchar of 30 and it is going to be having a default value, let's say ABC. So now what this means is I'm going to create a new table which will be having a column called institute name, which will always be defaulted to ABC. Now let's try to run it and insert the values. I'm going to run this. Yeah, table gets created. Let's try to insert values. Student test2 values. ID is 10. Course ID is something like 11. And I'm not going to give values because I want the default value to be added. Student name is something like Sylvia. That's it. Okay, now when I run this, let's see how does it work. Now when you run it, you are getting an error saying column count doesn't match value count. What we mean by that is, if I take the table, I basically find 4 columns, right? ID, course ID, institute name, student name, 4 columns. But when you're trying to insert, you're giving values only for 3 columns. So certainly there is a mismatch. That is the error. But the reason why you haven't provided the institute name is you want to go by the default value, right? So then where comes or how I can handle it? Simple. When you are missing any one particular column, when you are missing to give any one particular column, then explicitly specify the order in which you are providing the value, like this: student underscore name, and then provide. Now what it will do is it will do a one-on-one match with all these values, which means you are left out with institute name because you want it to go by the default value. Now let's run this. Okay, now as you see, no error. Now let's try to see the values also so that I can cross check whether the default value is taken or not. Correct? So go ahead and run it. Can you see the default value say ABC comes? Nowhere I have given the institute name as ABC, but by the table create syntax, you have directed the institute name to hold the value ABC in it. Got it? Now suppose for some reason I want to change the institute name. I know students studying under the institute will always be sharing the same institute name, but for some reason, let's take a scenario wherein you are expected to give a new value over there. Let's say XYZ. Okay. Then when you manually insert the value, ideally it will not throw an error. Okay, the primary key is getting violated because a combination of ID and prime ID and course ID should be unique. So I'm having that changed. Now if you run it, it is not throwing me any error. I have given a new value called XYZ, which simply tells you by default I will give ABC to my institute name. But the moment I get a value from the user for an institute name, this will be overridden with whatever new value that you have provided. So to cross check, go and run a select statement. You could see the XYZ new value comes, which tells you the default value will always be there provided no value comes from the user. Okay, hope that's clear. If not, please do ask your questions on the chat sections. The next is unique operator. As the name clearly tells you, it expects unique values, which means it is not expecting duplicate values inside my table. So I'm going to create again a new table. Let's take a simple syntax just to save some time. So student test 3, I call ID, course ID, student name, and a primary combo of ID and course ID. Okay, I'm taking this primary key also now so that things become simple. Now I'm going to enforce a constraint here called unique, which means I want the ID column here to be unique. Now let's run this and let's insert values also. 10, 11, and some name, right? And then the next time when I give, I have to make sure that I'm giving unique values, not the repeated values. Now let's see how this statement work. I'm writing the first two lines first. They get inserted. Yes, great. The moment I inserted the third entry, which is not satisfying my unique constraint because I'm giving the same ID one more time, it is telling me an error for duplicate entry 10 for the key ID. So because I have been expected to give only unique values inside my ID call. That's again pretty simple, unique constraint. Not null constraint is I don't want the value for a particular column to be empty, right? For example, take this. I'm going to create a test for. I want this to be not null. Now, by default, every column will accept a null value inside. But the moment I create something with a not null is, what will happen is, see here, test 4. I'm going to feed a null here on the very first column. Now see what will happen. Can you see the error? Column ID cannot be null, which means you must provide some meaningful value there. You cannot keep the ID to be empty or null. Now, by default, when you have a primary key, it will also have the not null constraint inside it, which means there has to be compulsorily a value provided inside primary key field. But then if you have any other constraints, it is not mandated to be having a not null. So if you want a particular column to be having always a proper value and cannot have null, then enforce this constraint called not null. Okay. The next and the last constraint is foreign key. Now, what do you mean by a foreign key? Now, foreign key basically establish relationships between tables. Now, you know about primary key now. Now, I'm going to create two tables. In one table, there will be an unique key, unique primary key column, and there will be an another table. The other table will be having a column which is same as the primary key of the first table. Now, in that case, the column on the second table will be referred as a foreign key. Let me quickly show you with an example. Example makes things very simple and much easy to understand. So I'm going to create an orders table, which is having order number as a primary key, and one more column called description of the order. Okay, just a simple table. This is called orders. Now, one more table I'm going to create, which is called sales. Now, in this table, sales ID is going to be my primary key because sales is nothing but the transaction, right? Now, I will also be having this order number, which was coming from the other table, which is orders. Okay. Now, and along with this, I will be having the product name also. What are the products that has been sold under this particular sale ID, and some amount. Obviously, there will be some amount involved, right? And after that, I'm going to write foreign key of order number, the column name that you are using here, and it is going to refer the order number column from the orders table. Now, understand this very carefully. What we are trying to do here is, see, this is a separate column called orders with just two fields. Now I'm going to create one more table called sales, which is having 3 fields inside, rather 4 fields inside. Okay. Now sales ID is going to be the unique column inside my sales table. And I'm going to have the order number. Now what I'm saying is, the order number that you are having here on the sales table is basically getting derived from the parent table. So now any order which has been placed under the orders table must definitely have an entry inside the sales table. See, if a person has made an order, then they will be purchasing it, right? It's not like I will make an order, but I'll not purchase. No. So you have created an order number, then certainly a transaction is going to happen for that particular order number. Now, how I can make sure, that is where the constraint called foreign key comes. Now, in this table, the order number that I have built is basically getting referenced or extracted from my parent table orders. That can be defined by references, which is basically directing to the orders table, and inside the orders table, the column name is ORD number or order number. Now try to run this. Okay. Now both the table has been created. Now let's try to insert values. So I'm going to give some ABC, some description. Let's not worry on the values. And this is a primary key, so make sure you're not giving repeated values. Correct? Now I have inserted these two. First table, two records have been inserted. Now listen very carefully. Insert into sales values. I'm going to initially give a sale ID. Let's have it as something like 101. I'm going to give an order number 10, which I have previously inserted in the orders table, and then some product name, something like uh, what do we write? Something like pen. Okay, some product and some amount. Now the same way, I'm going to insert one more record. Remember, the sales number again is a primary key. So to please remember to insert a new number, not the same number. Now I'm going to give 11. Okay. And this is, let's call it as pencil. And maybe I'll have 50. Now the third entry I'm going to give a very valid sales ID, PK, not repeated. Perfect. But I'm going to give something called 12. But do we have this 12 available on the orders table? Now, can I make a purchase for which I haven't made an order? Is it logically valid? My question is, can I purchase something which I haven't ordered? Certainly not. Correct. Right? Now, how to check that? See, first I'm running these two. These two statements are valid. Why they are valid? Because these are the order numbers and these order numbers have been placed. Now see what will happen when I run this. The moment when I run this, it is saying cannot update or add a child row, a foreign key constraint fails, which means the order number that you are keeping here, it was not even placed. Now, how I can have a record for a transaction which was not even been ordered? Is things clear here? Right? So please understand this. FK are very, very, very important, and they are being pretty much you will have foreign key in most of the real case projects. Fine. So now these, please do practice them too. So I will quickly save this so that, yeah. So now these are the different, these are the different 6 constraints. I have explained all of them, all the 6, and we have even seen them in the lab on how it can be applied. Now moving on to some of the aggregate and scalar based functions. Okay. Now, these are also pretty much important. Now we are slightly moving to the next level of your SQL. So far what we have seen are the very basic level with very minimum level of complexity involved in it. So now we are slightly going on to the next level, wherein we are going to learn something called aggregate and scalar functions. Now, what do you mean by aggregate? Aggregate is, as we have seen on our group by class itself, for multiple values, I'm going to get one single value. For example, I'm having list of building ages. I'm going to find out what is a minimum building age out of it. Or I'm going to get a list of amount for which sales has happened. I'm going to find the average sales. Like this, we can calculate an aggregate. So when it comes to aggregate, for multiple values, I will finally end up in getting one single value. Scalar functions, on the other hand, for every single value that you are supplying, you will be basically getting one value for that. Let me show you that, but let's first cover these aggregate functions. These functions, have you remember, just now we have seen in group by, right? Average, count, min, max, and sum. Now, in a group by, we did group within a country or within a building, and then we have calculated all this file. Now, without that also, like on a wider level, without any country specific data, like irrespective of the country, if I want to find what is the average gold medal. Remember in Olympics we did that? I'm going to our Olympics table now. Right? This is my Olympic. Now, what we did earlier was with respect to country wise, I found out what is the average gold medals or average silver medals and so on. But now, irrespective of any of those countries or irrespective of any of that constraints, if I want to find the average number of total medals, okay, irrespective of any condition, that is the part here. Now, similarly, minimum of silver medal and similarly max of gold medals and from Olympic. Now, what this one will basically do, it will help me find out for all the 110 records, it will give me one single entry for average of total. Minimum of silver is no, there are 0 silvers obtained by people and hence it is minimum silver, and the maximum is 8. So the maximum number of gold medals obtained by a person is 8, which is very huge for in the context of a single person achieving it, right? So these are aggregate functions. So all the same 5 functions I can calculate with respect to a particular attribute or without a particular attribute on overall the entire records. So that is basically called aggregate function. And that's why I said the aggregate functions will basically help you to get only one entry out of all the 1,000 entries that you have on your table. So I have 1,000 entries for medals. I want to find the average. So it will take all those 1,000 entries, sum them, divide them, and give me the average. And the same applies for all the other aggregate functions too. Okay. Now next is scalar functions. Scalar functions are, again, as I said before, every function will give one value. For example, when I take length, now I'm applying the length function on top of a name field. So suppose if I have some 15 names inside my table, then I will end up in getting 15 output for the length. That is what scalar functions. So for every row, these functions will yield a value, will give a value, unlike your aggregate functions. So you know what will happen when I write a length of. Any idea what will happen when I do an L trim of? L trim. Have you heard this or have you used this before? What do you think will happen when I do an L trim? I give you a clue. It can be applied on a string based field. Only on a string field, by the way. Okay, no, not like that. See, it's basically when you do a L trim, any leading spaces on my value, it will trim out. It will take it out. Okay, let me quickly show them on the lab. So let's come to let's pick up any one column. Mm, we'll take the Olympic only. Yeah, because just now we have loaded, we are good with that table. So I'm going to find the name and then I'm going to find the length of the name from my Olympic. So it's going to tell me how many characters are there inside every name. That is nothing but my length of name. Now, similarly, I can do an L trim, but then L trim will basically help me in finding out any leading spaces are there, if at all it is there. Okay, so now in my case, I'm not sure I'm having entries with that, but if in case a column comes up with some leading space inside it, then the space will basically cut off. The same applies with your R trim. R trim applies for your right side. That's the only difference. So any leading spaces or any trailing spaces will be cut off, will be taken off when you come up with L trim or R trim functions. Similarly, I can do a concat. Now, when I take a concat, it is basically like combining the values of two columns. I'll show you this. So I'm going to combine my name and the country as something like name country. Now see how the output will look like. Now, when you see the output of my concat, you can basically get the name of the person and underscore and the country for which the particular person is playing. So concat is basically to combine the values of two or three columns. You can simply concat them without a separator, but having a separator will ideally help you to differentiate the end of your name and the starting of your country. So it is highly recommended to have a concatenation symbol in between. Right? Make sense? Perfect. The next is replace. What do we mean by an replace? So suppose if I find a particular column, if it contains some letters, then I just want to replace it. For example, let me take the name field. No, let me take the country field. I have the country field, right? In my country, I have under United States, there is a word called states. Now, wherever I want this, I'm seeing the states, I just want to replace that to something like just state, just to be a singular, just to show you an example, okay? You can replace it from anything to anything. Now, since you can find this multiple number of times, I'm taking this. Can you see what's happening? This is the actual country and this is a replaced country. Can you see the S is not coming? Here also, here also, here also. Now, wherever it finds states, it will change that into state when you are using the replace function. And also remember the fact that these changes will ideally be not getting reflected on your table. It is not that on the existing table you are changing or you are doing this replace. On your output only you want to display them like this. The original country in the table is still there. If at all you want to change the original country, you have to write the update command that you have used earlier yesterday. Now, all these statements will basically are scalar functions, which helps me to see how the output will look like if I apply these functions on my columns. So length, rtrim, ltrim, concat, replace. Similarly, upper, lower. Okay, let me show you upper and lower. They are pretty same, they are pretty simple. So I'm writing an upper of country. I'm writing, they are nothing but represents the case. Okay, see what happens. When you do an upper of country, everything gets changed into the uppercase, lowercase, and the original country. If you can observe closely, you can find the difference. In the original country, U comes with capital U and S comes with capital S. That ideally get changed when you are lowering it out. And similarly in the upper, everything has been changed into the uppercase. Right? Then comes the round function. Round function is pretty much useful in terms of decimal numbers. Right, like this. I don't have a decimal number field here, so I'm directly taking a value here and trying to round them up. I can write something like round of 56.9. Can you see the rounded value of it? Now, how it becomes 57? Because after decimal, if it is 5 or greater than 5, it will add one number to the whole digit, and that's why it becomes 57. Similarly, if I run like this, 56.3, now it will be just 56, right? Can you see? Getting it, friends? Similarly, I have given the round, but you can also try out floor and seal. These are little functions which is similar to that. Okay, I'll show them. So seal and floor. Okay, now what will happen when I do a seal and a floor? Floor will lower them out even though the decimal value is greater than 5. It will stick with the original number when it comes to whole digit. But on the seal is very similar to your round function, wherein if it is higher number, it gets incremented by 1. You can either use a round function to achieve that, or you can use the seal function to achieve that. Both will give you, if at all the decimal digit starts from 5. Okay, round is done. The next is substring. So these are pretty much very simple functions. So what will happen when you do a substring is just specify the column name and specify their indexes. For example, I'm writing substring of country, and in country I'm going to have 1,3 and then the actual country and then from Olympic. Now what it will do, initially it will take 1 to 3, which basically means the first 3 values and then the entire country, right? That's a substring. You can specify any such indexes. Maybe I want to start it from 3 and go all the way up to 6. Like this. That's a substring. Now similarly, okay, length I have, sorry, it's been repeated. And coiles. Coiles and if null are pretty much same. What it will basically do is when any particular column comes with a null value inside it, then it will replace that null value with whatever value being provided here. So I can't take this Olympic table because Olympic table is not having any records with null values inside it. Let's take any one student table that we have created before. Okay, let's try to insert values on the student table with null so I can simulate the situation for you. So I'm going to create a student file. I'm going to accept null values here. Then only I can show you. Now insert into student test file values. I'm going to give null here, course ID something and some name. Similarly, this again 13 and some names. And again, now a proper value here, right? Let's try to load all the three. Yes. Now what I'm going to do, I'm going to take my ID. Now initially let's take the ID and then let's apply the coalesce function. So now what this coalesce will basically do is it will take your field name and then it will check whether if the value of ID is null, then replace that with the default number, say 99. Okay, so you don't want the entry to be kept null, then you can use the coalesce function. See, the actual ID is null, but then the coalesce is giving you 99 because in these two rows, the IDs are coming as null. Now, the usage of a coalesce is if at all a null comes, change it into 99. But if a valid comes, keep the valid value only. Right? The third record is having just a 10, so keep it as a 10 itself. But then when it comes up with a null, you have to change the null with whatever value that you are getting on the coalesce. Now the same applies to your if null also. Instead of coalesce, you can write an if null and you pass the value, it gets changed. For example, I'll show that as well, which is also a Scala function. So now I'm going to change it to 100. So whenever that is a null, it gets changed to 100. So the same applies in your if null and coalesce. So if you are encountering some null values, but you don't want those null values to be displayed, then you can use these two functions. Similarly, we have a date wise operator. So all these 5 stuffs that you see, all these 5 are related to date operations. So to show you that, let me write date diff. And remember the fact in your RDBMS, not just in MySQL, in your RDBMS, the date should always come in this format, YY MMTD. So let's see how it goes. So I'm going to take 2 dates here. So I'm going to take 2020 and then 2020-04-04. So now when I do this date div function, you can actually pass 2 columns which comes up with date in this pattern. But right now I'm directly hard coding it. You can give any column name also. For example, if you have a manufacturing date and an expiry date, and you want the difference between them, you can pass it. So if you find the difference, it says is minus 62, because this is the least date and this is the higher date. If I give 4 here and if I give 2 here, then accordingly the value will be positive, right? So make sure the higher date has been given, or even if it happens to be a negative date, you can write an absolute function to convert it into a positive value. Or if you want, sometimes we expect the difference to be negative so that we will identify that this date comes first. So accordingly, we can take it. So the date div function is basically going to help us to identify the difference between two dates. Okay. Similarly, we can have the day, month, year, and the last day directly being applied on the date function. So see here. So this is date function. This is month. And this is year. Let's have it like 2009. And last day of that particular date. Okay. So these are some of the date related function, again scalar function. So if you see, the day of it is 2. The month over here is 2, because remember the syntax is y, d. So the month is obviously 2. And the year is alone. The year alone has been this. And the last day of this particular date in terms of its month, which is on March. March contained 31, the last day. So it gives 30. Okay. So these are some of the date-based functions which can help us to handle date-related operations. Now, similarly, you can handle joins with different tables. So when we say we are interested in performing join with different tables, it is basically like I'm trying to combine the records between two tables. So now how you can combine the records, I'll show. So I'll quickly create two tables and then I will show how you can perform the joins. Now, two things we need to understand when we are looking out for joining them, either through union or through uh, uh, join. I think we spoke about this yesterday partially, but yes. So I'm having this as student name and varchar. Similarly, I also want to create student underscore academics, and here also I will have a student number which will be an integer, the grade which will be again an integer, the rank which will be again an integer. Okay, now let's run this and build tables. I will create two academics table. I'll show you why I'm doing that a little later. Academics underscore 2 like this. So let's run all three. Okay. Now insert values in it. Actually, you will be getting this complete session as a YouTube video. So you will be getting the link. You can check out on their YouTube channel Learnbay. there they will be completely recording this and it will be uploaded. So you can find this entire recording there. Okay, I'll just insert two values. Insert into academics. Now I'll give one value which is matching, and I will be giving ranks as, let's say, 1. And one value which is not matching between both the tables. Now let's see what's going to happen when I do a run on it. Okay, student underscore academics. Okay. Now let's see what's going to happen when I try to perform a join between them. Now, when I'm interested in performing a join between them, basically I'm going for the joining column to be student number, because that is going to be the common column between them. And after that, I can read whatever columns I want. Now, so I'm going to write, just hold on with my statement. I'll explain what is this P dot. You might understand when I'm writing, but if not, just hold on with me. E dot ranks from student underscore personal P inner join student underscore academics A on P dot student underscore number. What we are actually trying to do here. Now I'm trying to combine the two tables, both of these two tables, through this field, which is basically my student number, and I'm trying to get their name, their grade, and marks. Now, when there is a matching student number, I will certainly get their grades and ranks. If there is no matching, then certainly I will not be having the value for their grades and ranks, which comes from my second table. Now, if we observe, I have only one value which is matched for the student number, say 10. So now when I run this query, I should only be getting 10, because 10 is only the common student number between both the tables. Right? Now this is your inner join. The same way we can try a left join also. Now when you do a left join, what basically will happen? It will give all the result of your inner join, and along with that, whatever is the left hand side table, if any extra values are coming on the left hand side table, that will also come. Now, if you see, this is my left side table, this is my right side table. My inner join yields me Anu, but along with that, I have Karthik on the left side, and hence Karthik will come. But that student Karthik is not present under the academic section, and hence his corresponding grade and ranks will be null. The same way, I can also handle right. Now, whatever happens on the left hand side, the reverse will happen for the right hand side. See, we have got the third person, but he or she is not having a name and a student number on my personal. Got it? So joins are very, very simple, just that you should understand how the left, right, and the inner join works. And all these three requires a mandate common column between whatever tables that I'm looking for to be linked with. Now, apart from your joining, which can be used to combine the tables, you can also use union keyword. Now, any idea what a union will do? Union will take every record from the first table and every record from the second table also. It does not need a mandate common column between them. So see, but one thing we need to understand before I do an union. Can you see an error being popped up here? Now, what does this error basically tells us is both the table that you are trying to perform union with must be having same number of columns. And that is what this error is also telling you. Select statements must have different number of columns because on my first table, which is personal, let me show you here on the left side. See here, personal table is having 2. But when I go to academics, the academics table is basically having 3. Now that is where the challenge is. So what we can do, I can take all the columns from my student personal and I will take only the student number and the grade. Now, number of columns in both the queries are satisfying. Here I got the 2, which is my student number and the name. And here I have got the student number and the grade. Now, like this, you can perform an union, but remember the fact whenever we are interested in union, then make sure the number of columns that you are reading from both the tables should ideally be the same. Is that clear? If you are not reading the same number of columns, then it will throw out an error saying you are having mismatched or not matched number of columns set. Okay, great. So when you are interested in combining multiple fields, multiple tables, just make sure you can achieve them either by using your join or by using your union class. And similarly, we also do have an other keyword called union all. Now, what is the simple difference between both works in the same way? The only difference is the union will give me only distinct values. Now, if a row is kind of being repeated, then it will not give the duplicate entry. It will give you only the very first entry. But then when you do an union all, even if there are duplicates, it will give everything. Okay, so basically, if you are interested in getting out the duplicate values also, then go ahead and have an union all. If you don't want, then you can stick with just union. Got it? So any questions so far? I will be sharing this with the Learnbay team. You can collect it from them. And also all these sessions will be available on their learning channels, so which we can refer if you want for practice in future. Great. So just a second. Please do let me know if you are having any questions parallelly. Okay, as a quick recap on what we have touched upon today, we start up. That's it. That's it, Sachin. So we have seen the union operations and the join operations and the different scalar functions, the aggregate functions, and your constraints, which can be basically applied on top of the tables. Right? So these are the areas that we have covered. And if you want me to explain any one particular area here, or if you're not clear on this, you can let me know. Otherwise, we are good. You want anything specific, Sachin? I'm asking as in whole SQL tutorial. No, so for webinar, these are the topics that we are planned to cover for you. When you come inside the data science as a course, wherein I will be handling the SQL module, wherein we will be seeing stuffs even more in a detailed way with a lot of some examples. So as a beginner, as you see, these are the fundamentals webinar, right? So these are the basics that a person must know if you want to step inside a skill, and slowly you have to upgrade yourselves with lot more extra areas. For the webinar, these are the topics that has been planned. On your entire SQL module under the course, there will be few more topics, but again, that will be in a much more detailed way. Fine, guys. So if we are not having any more question, let me check whether we do have people from Learnbay.